Hey, how's it going? Today in this video, I'm going to show you how to set up and use TypeORM specifically with NestJS, and I'll show you how to do queries, how to connect to a database, how to do migrations, all of those base fundamentals. To create a new NestJS application, you usually would do that through the Nest CLI, so make sure to install that globally. So you do npm install -g nestjs/CLI. Once you have that installed, just use it to do nest new and then give it a project name, TypeORM. So like a package manager, I'll use npm. That's going to install real quick. All right, so now I'm in VS Code, but I'm back in the terminal because I need to install a couple packages. Make sure to install nestjs/TypeORM, TypeORM itself, and then the database driver of your choice. Here I'm going to use SQLite just because it's very easy to set up for a tutorial, but you can use MySQL, Postgres, whatever database you might have ready to use. All right, with those things installed, the first thing we're going to do is we're going to go into app module, and we're going to add an import in here that basically configures our database connection. To do that, we're going to do TypeORM module for root, and this takes in an object that allows you to pass in, what kind of database you're using, the credentials that you have. So for example, in our case, we're going to do type SQLite. And as you can see, actually, as I'm typing there, right, it shows you all the different databases database drivers that it supports. We're going to use SQLite, and we're going to provide database. This is going to be the file name of the created SQLite database. We're going to call it, let's just call it db.sqlite. All right, and if you were using a different database type, like let's say you were using MySQL here, usually you would also have to pass in credentials here, like you might have username, something, password, and so on, right? Our SQLite here, since it's designed to kind of just work off of a file locally, we don't really have credentials. All right, next is because TypeORM is an ORM, right? It's meant to help you represent database entities into your code. So we need to specify an entities here, and this takes an array, and basically you can import individual entities, or you can give it a path to say, here's where I can find your entities. In our case, we're going to do dist, and then we'll give it a pattern that says anything that has entity.js in the file name is an entity, right? Pretty simple. Now you might be wondering, why are we looking for entities within dist and with JavaScript files when our source code is in TypeScript? That's because when you run NestJS, it's working off of the transpiled code. So we can't reference TypeScript files in here. It'll show an error, and I can maybe show that later. But for now, set it up like this and it should work. There's one more thing we're going to add in here real quick. We're going to do synchronize through. Now what synchronize does is you can pause the screen here if you want to read it. But basically, it's going to look at our entities, and it's automatically going to push the schema into our SQLite database, right? It's like, think of it as like automatic migrations. And it's definitely only meant for development, kind of like quick projects like this. In reality, you should be using migrations, which I'll show more towards the end of the video. But for now, we're going to do synchronize just to kind of get things going. All right, so now that we have the database connection configured, we can go ahead and build something to actually do queries off of our database. So what we're going to do is we're going to create a basic CRUD API for users, right? We want to be able to create, read, update, delete users. Now we're going to use the Nest CLI to generate a lot of the boilerplate for us. So we're going to do nestg resource users, and it's going to ask you, what do you want to use? We're going to do REST API, and would you like to generate CRUD endpoints? We'll say yes, right? And you can see that it creates a bunch of files. We now have a users directory. So if we go back to our app module, you'll see that there's now a users module in here. And if we look into our code, there is now a new folder here, users, with a couple of things in it, right? So it has its own users module. It's got its own users controller, a users service, and the big one to notice is there is an entity file here, right? By convention, they're kind of recommending put your entities in an entity folder. And as you can see, this has the file name .entity that we're looking for. So right now it's just an empty user class. And what we want to do is we want to say, hey, TypeORM, this user class should represent a user table in our database. And to achieve that, you gotta add a decorator entity, right, from TypeORM. So we're saying this now maps to an entity in my database, or basically a table. And then we have to add our columns. So let's say that our user has a distinct unique identifier, and just to start, we'll give them a name. Now, right now, these are just class properties. It still doesn't tell TypeORM that these are columns to the table. So to do that, usually you would add similarly a column decorator from TypeORM. Now for primary keys, there's a special decorator you can use there if you want it to be auto-generated, right? So for a number database column, usually if you're using that an ID, you might want to auto-increment it, right? So that every time you insert a new user, the ID goes up by 1. And TypeORM has support for that. We're gonna do TypeORM primary generated column, right? So you can kind of imagine that this is an auto incrementing int, and this is a a varchar problem. All right, so at this point we can actually go ahead and run our application. We're gonna do npm run start dev, and if you're following along, you should not expect any errors in the terminal. But once it's running, you'll notice that there's a new db.sqlite here, which is actually representing our database. So when I click on this, you'll notice that actually brings up a database viewer for me. Notice that our user table is already there, and it has an ID and a name, just like our entity. And that's actually the synchronize that we had in our configuration here. That's kind of like how it works. So for example, if I add a new one, and I'll just do other, when my application sort of reruns, if we take a look at our database, back to the user table, it now has an other column, right? So it synchronizes our changes. Again, I just want to remind that this is really useful for initial kind of quick development, but in production, really what you probably want to do is a migration. Talk about that again later. All right, so now we have the users table, and we want to start adding data to it. We want to be able to query it. Right, again, we're going to do create, read, update, delete. So let's take a look at our code. So remember that we have a users controller that we generated earlier, and notice that it has a couple of things pre-made for us, right? There's a route on /users post, which is going to create, and then there's a find all on get /users. There's one for just getting one user, and then updating and deleting, right? So your basic CRUD. But this is the boilerplate. It doesn't have the actual logic within the service to actually talk to our database to perform those queries. So that's what we're going to do next. So now that we have our user's entity, we now sort of have to register that within the modules that we're going to use it into. So the way to do that is, we have a users module. We're going to add an imports in here, and we're going to do TypeORM module.forFeature, and this takes in an array of entities, right? So we're going to import our users entity. Now, once you have that, what that enables us to do is we can now inject our repository into the user service. So we're going to add a constructor, and if you've watched my other videos with NestJS is very big on, dependency injection. So we're effectively injecting a, think of it like a connection to this specific repository for the user's entity. So we're going to do inject repository, pass in our user entity in here, and let's give it a name, users repository. All right, so now we're pretty much ready to write queries. So let's start implementing each of these methods. So how do you do inserts into our users table using TypeORM? Well, first of all, you need the data, right? And you can see it's already kind of hooked up for us. We have a create user DTO, which has a shape of this, which is empty. We got to fill this in first. Now with our user entity, since we have an auto incrementing ID here, the only thing that we can really pass in when we're creating a new user is the name. So we'll copy that and we'll add that to our DTO. Now, real quick, you might be wondering what's the difference between a DTO and an entity. Think of it as the entity is a representation of your table. It describes your database table, right? It says that this is a column that is a string. If you had different data types, you could pass in information in here to specify what type of column that is. Whereas a DTO, a data transfer object, is simply just a typed representation of data that's coming in from your client, right? It doesn't necessarily represent the table, although it very well might have pretty much a lot of the same field. So I hope that makes sense. So now that we have that, let's go back into our user service. So with TypeORM, there's a bunch of different ways that you can interact with the database. One of those ways that is promoted in TypeORM specifically is the repository pattern, right? The repository API. And if you look in the TypeORM documentation, there's a section there specifically on the repository API. So what we're gonna do, we're gonna cover some of the basics of this, right? So how do you insert items into your database? First, you need to create sort of an object. We're gonna do new user equals this dot users repository dot create, and we're gonna pass in here our create user DTO. And to a degree, this doesn't really do much yet. It doesn't actually insert to your table. It just creates think of it as an object that's ready to be saved and inserted into our table. So how do we actually save? We're gonna do this dot users repository dot save new user. And you can see that save returns a promise of a user, right? So it brings back the thing that you just inserted to the database. You could also use insert, which is sort of the alternative API, but you'll notice that it returns the insert result. It doesn't return the inserted user, the object that you just inserted. So in my mind, usually you want to return to your client the thing that you just inserted. So usually you want to do the create and save combo, and you'll see this pattern in a lot of the other ones that we'll implement in a second here. Now I'll show you this stuff actually working with our application in a second here, but why don't we go ahead and wrap up a lot of the other implementations here to do our CRUD. So in TypeORM, how do you do find all? You just do this dot your repository dot find. Pretty simple, right? So that's equivalent to like a select star, from user. All right, so you might be wondering, what if you had a more complex query than just a basic select star, right? So find actually allows you to pass in a bunch of options to it. And I'm not going to cover all of the different things that you can do with it, but I highly recommend you check out the find options documentation. But at a high level, anytime you're trying to do a select query, usually find will have some kind of support for that. So for example, maybe you want to only just select specific columns. There's a way to pass in relations, which is basically like doing joins once you set up relations with your entities. I have a video on TypeORM relations if you're interested. And then, you can do ordering. You can do, if you're trying to do pagination, it has support for, offset via, skip and take, new limit, so on and so forth, right? There's a bunch of things here that you can do with find if you're trying to select data. So make sure to check out the rest of the options here. So how do we do a find one? Now, based on what I just showed you, you might assume that we would do something like users repository dot find where ID equals ID, and you can do that. That totally will work. However, by design, find is meant to do a select that returns multiple things. So to kind of get around that, there's actually a utility where you can do find one by, and that actually is the equivalent of the one that we just did. However, it returns, as you can see, a single user, right? So you don't have to deal with the array. So it's a kind of a nice, if you know you're only selecting one thing, you should use find one. So let's do update, and you can see it's already set up to pass in the ID of the user that we're trying to update, as well as the user DTO, which actually just extends create user DTO. So it already has what we want in it, which is the name. So the typical way to do updates with the repository pattern is first, we need to find the thing that we're trying to update. We make updates to it, and then we do save again, kind of like what we have here. So first we're gonna find a user, and we can actually just use our existing query here. We're just going to forward the ID in here, and remember that's going to return us a promise of a user. So this should be async wait. Now to make changes to it, we just got to perform the changes and then hit save. So we're going to do users repository dot save, and then we're going to pass in here the updated changed user. So to do that, we're just going to we'll spread the user, and then we'll spread the updates, and that's it. Again, there is, as you can see here, there's an extra select query here. If you're trying to avoid that, you can also do, as an alternative, this.users repository.update. So it would look something like this. And then I believe we can just forward the update user DTO here. Right, so this is sort of your alternative to the find one and save. However, again, with update, kind of like we talked about with insert as an alternative to create and save earlier, it only returns the query result, but it doesn't return the actual updated user, which typically with APIs, you actually want to return the updated user. So I would actually recommend you use this API. Now for remove, again, same exact thing. We can copy this async and return this dot users repository dot remove user. Again, what does remove return? It returns you the removed record, the deleted record. And again, same thing. Alternative to this would be return this dot users repository dot delete, which kind of has the same API as update earlier, where it takes in the criteria, which in this case would be the ID, and then it returns a delete result, right? So it'll tell you that, a row got deleted, but it doesn't tell you the actual data that got deleted. So again, it's more of a preference thing. If you want to return the thing that got removed or got updated, it's usually better to use this API. All right, so I hope that kind of makes sense. And let's actually start running our application again if it's not already running. And let's go test our API to see if our CRUD works. So I'm going to use Thunder Client here, which is sort of like Postman, and our app is in localhost 3000. So if I go get/users, you'll see that it returns me an empty array down here because our database is empty. But if we do a post and provide it with a JSON body we said our create DTO has a name in it. So I'll provide one with Dustin, hit send. You can see that it's 201 created and it returned me the created user. Again, that's a benefit of us doing the save method. Do another one, Olive, send. And you can see our ID now is 2 here because you can see our auto incrementing column kind of working as we add insert to the database. And if we go back to our get/users, you'll get back an array of Dustin and Olive. And now we can test our find one. Let's do user/1. That's going to bring me back just Dustin. 2, it's going to bring me back Olive. Try our update. So we're going to do a patch. So if we were to update the user with ID 2, we were to change the name to Olivia, send. Again, notice that it brings us back the updated database record. And just for a sanity check, if we go to get/users, you'll see that we now have Dustin and Olivia, right? So our update worked. Let's go ahead and try our delete. Let's delete user 1. So my expectation here is that, we'll end up with just Olivia left in the database. So we'll do delete, send. And again, the response has the deleted object, which was what I was talking about. And if we do a get of /users, now we have just Olivia. All right, so back in the code, really that is the very bare bones basic fundamentals that you need to know with TypeORM to do your CRUD. Now, in a real application, obviously, queries are not this simple. And you might not even be familiar with the find API to start. With that said, if you're more familiar with SQL, which you should know SQL anyways, you could also do custom queries. For example, you can do create query builder. And again, I really recommend you go through the documentation on how to use a query builder. There's a lot in here for me to cover in one video, but if any of you want me to do a crash course of a more deeper dive into this stuff, let me know in the comments. But at a high level, you can see that you can do create query builder, and then the syntax largely looks like regular SQL for the most part. You have a best example where you have select, from, where, etc. The only thing that's different is that typically, because this is a query builder for the user's repository, usually you don't have to provide the from, because it's already connected to the user table, right? So that's kind of one more way to write your queries. But again, I highly recommend, if you're going to use TypeORM anyways, might as well learn about the find API, because it will save you a lot of time from writing the typical queries. But yeah, you can use the create query builder for more complex ones. All right, so that pretty much wraps up our basic setup, how to do CRUD. One last thing I wanted to talk about here is how to do migrations. I talked about doing that earlier. All right, so earlier we talked about, synchronizing, how that automatically synchronizes your database to your entities. However, in a production environment, that's very dangerous, right? Because at the point that it synchronizes, it might wipe out some data for you, which you don't want to happen. So in production, you actually don't want to use synchronize, right? This will actually default to false, so you don't have to add that. So let's talk about how to do migrations. TypeORM actually has a very useful CLI that will automatically look at your entities and try to generate the migrations for you. Now, there is one catch, however, is that CLI also needs to work off of the same object here. So we want to actually move this to a different file so that both the code and the CLI has access to it. So here's what we're going to do. Within the root, outside of src, actually, we're going to create a new folder. We'll call that db. And within db, I'm just going to paste in, just to save you some time of typing it out again, basically the same object, except I added a new thing here, which is the migrations path. So kind of like similar to how we're defining where is our entities, we're defining the CLI, where should it find our migrations. And we're going to say that that's going to end up in a folder inside DB that will be created later, right? So we're exporting the data source options. So we need to update our code to use that data source options. That way it's defined in one place. So we'll do data source options here, right? And make sure to import that from the new location. And then for the CLI, it actually needs that, not just the options, but it needs the actual instance of a data source from TypeORM, which is really its own kind of new entity for a connection to a database. This is the data source, pretty much replaced what once was ORM config from the older version of TypeORM. Now everything is just a data source. So now that we have that in place, I'm actually going to delete db.sqlite here, because I want to start from scratch so you guys can kind of see the workflow. Start dev again, that way it creates it again from scratch, but this time without the synchronize, it's just going to be an empty database. There's no users table in there. And instead, we're going to use migrations to create that table. First, like I mentioned, there is a TypeORM CLI that you can just use via npx, or you can install it globally. So we're going to create a new npm script in our package.json. We're going to call it TypeORM, and that's just going to do npx TypeORM, and then we have to use the -d flag to tell it, where is our data source file. Again, same thing here. We're actually looking for the file in dist. We're not looking for the source file, because we're working off of the JavaScript, not the source TypeScript. So all of our TypeORM CLI is pretty much going to be using this script as a base. And actually, because we are working off of the JavaScript, that means we actually want to do a build here. That way, everything gets transpiled to the dist, and then we can work off of that. All right, so just to save you some time of me typing more scripts here, I'm just going to paste in a couple of things. So I added migration generate, which is just running our TypeORM script, but it specifically is running this command. So it would be the equivalent of typing in your terminal npx TypeORM migration generate, right? But we're putting it into our npm script just for ease of use. That way you don't have to keep typing out this thing, which actually would also need like this, right? So that would be kind of painful to keep typing every time, right? So let's test this out. We're going to do npm run migration generate, and then we're going to do --. We're going to provide it with the path to where our mutations will be, and then the name of our migration here, we're just going to call it new migration. And you can see that it's going to do our build, and then it created a migration at this file, and you can see there's a timestamp there. Let's go ahead and open that. That migration looks like this, and you can see that it has the create table user. Now, how did it know to generate that? Well, what it does is, because our data source config has the entities in there, it looks through all of our entities and then it connects to the database and it kind of says what's mismatching here. It notices that I have an entity database, we don't have a users table, but we have a users entity. So then it generates a migration that creates the users table in the first place. First, let's run our migration. We're going to do npm run migration run, right? So we're running this guy. The first time you run migration, it's going to create a migrations table that keeps track of all the migrations that you ran. And then it starts to look at your migration files. So remember, that's now in db/migrations. It looks at all our files and it looks at the database migrations table to see which migrations have not run yet. And if there's anything pending, it's going to run that. So let's take a look at our db.SQLite, and you'll notice that now our users table is there and the migrations table tracks which file has already ran. And at this point, we can run our application and do our CRUD, and we should be able to work with it now because the table exists. Now let's imagine a scenario where requirements changed and your product owner says, now we need to keep track of the users, I don't know, something. Let's add a new column in here. Let's imagine this is also a varchar, right? So now your entity has changed. Your entity is now out of sync with the database. So what do? You run migration generate again, and let's change the name here. Next migration. All right, so we've got our migration created. Let's take a look at what that file looks like. Now you can see that what it's trying to do is it actually creates a temporary table. It inserts the existing data into that, from the old users table, and then it drops the old table and then renames the temporary one to be the new user table. I'm not sure if it's because we're using SQLite, but in some cases, if it knows that it can just do an alter table, I've seen it just do an alter table instead of doing it just using a temporary table here. Or maybe something has changed with TypeORM, I'm not sure. But the general idea to it is that each step that changes your schema is represented in a new migration, and it auto generates the migrations for you. So the workflow becomes basically your entities become the source of truth of what your current schema is supposed to be, and as long as you keep generating migrations off of that, it'll keep your code and your database in sync. Now that's one way to do it. You don't have to do it that way. You could also use, instead of migration generate, you can do migration create, which will just create you an empty migration file, and you can just write the SQL yourself manually. So you don't have to generate. And then I didn't cover it, but you can also do migration revert. So if you already ran a migration, you can also revert that run. And again, it looks at the database table to see, what is the file name that is there. And when you run a revert, it's going to take the thing that's at the top, or the thing that ran last. And then it's going to look at your file to see what that is. And it's going to do the down here. That's why there's an up and down in a migration. That way, when you run a migration, it does up. If you revert, it's going to do down, right? So for example, in our original migration, the down is deleting the table. All right, guys, hopefully that was useful to you in some way if you're just getting started with TypeORM. Anyways, thanks. I'll see you in the next one.